Hello everyone. So today we are going to discuss for NEET chemistry. Correct. This board I have changed. Let's see how the light reflection it is coming. So in today's class, what I am going to discuss it. This is for NEET. Okay. NEET 2023. Right. So today, as I told you, we will discuss about mole concept. So today, what all we are going to discuss. First will be mole concept. In that, we will discuss molecular formula and mole, whatever is there. Okay, molar mass. Better we call it molar mass. Then we will deal with percentage composition. Okay, and then next we will deal with empirical formula. Okay, empirical formula, and together we will discuss it. Empirical formula and molecular formula. Suppose they have given some composition, percentage composition, and they are saying that what will be its empirical formula and what is its molecular formula. That we are going to discuss it. Then next, what we are going to discuss it, the stoichiometric. Okay, stoichiometric and stoichiometric values, whatever the coefficient is there. Okay, stoichiometric and stoichiometric coefficient we are going to discuss it. Next we are going to discuss it, limiting reagent. Okay, limiting reagent. So these things we are going to discuss it today in this current lectures, and then based on that we will do some exercises, and then we will conclude this lecture. Correct. So now we'll start with mole concept. So how this word came, mole concept, right? Why this is required for mole concept? Why not 1 atom, 2 atom, 3 atom for hydrogen? Why we can't count that? Okay, concept we are going to deal with mole concept and molar mass, right? So why this is required, molar mass and mole concept? See you. In chemistry, the molecule atom which we are dealing with, it's a very tiny particle which we can't see in our neglected eyes, right? We need microscope to see this, correct? So these are microscopic particles, so the size will be very less. Likewise, the number will be more, right? If we are talking about atom, so there will be as many atom like 6.022 into 10 to the power 23, then only it will be 1 mole. 1 dozen banana means it is 12 items, right? 12 banana, right? So likewise in chemistry also, the number is used, size is very small, correct? So to handle this for the calculation, better calculation, okay, what we are doing, we are just keeping a number, a unified unit we need, okay? That unit, the magnitude of that unit, the value is 6.022 into 10 to the power 23. You can say particles, you can say atoms, okay, you can say ion, you can say molecule, whatever you want, but the number will be 6.022 into 10 to the power 23, and this number is called Avogadro numbers, and we are just representing this with Na, okay, subscript A. So Na is the Avogadro's number. And then how we are getting this Avogadro's number? By keeping in mind that carbon isotope, right? That 12 carbon isotope. So now we are going to write for 1 mole. So 1 mole of any entities or any particles or 1 mole of mass contains the entities, okay? 1 mole mass, 1 mole of any substance's mass contains as many particles or entities as we have for 12 gram of carbon 12 isotope. Okay, it may know that for 1 atom of the carbon, okay, 1 second, 1 atom, okay, or we can say it atomic mass of carbon, okay, how much it is? 1.99 into 10 to the power minus 23 gram, right? This is for 1 atom of carbon, right? This is the mass of 1 atom of carbon. Now we want it for the 1 mole of carbon, we know already that 1 mole of carbon weight is 12 gram. So now just find out the numbers. Okay, in this 12 gram, how many numbers of carbon are present? So how you are going to find it? So number of carbon atom. Okay, number of carbon atom. Okay, number of carbon atoms equal to, we know that 12 gram per mole we have, per mole of carbon, and then 1 carbon atom weight, like atomic weight of carbon. How much atomic weight of carbon? It is 1.99 into 10 to the power minus 23 gram, right? Now just divide this one. How much it is come? This 10 to the power minus 23 will go up. 10 to the power minus 3 will go up, and then it will be 10 to the power 23, and now it is approximately 2. So 2 and 12, it will be like 6, right? 6 into 10 to the power 23. So approximately it is coming 6.022 into 10 to the power 23, and this is the number which already we have discussed, like Avogadro's number, right? So 1 mole of carbon, okay, 1 mole of carbon contains 6.022 into 10 to the power 23, and this is the reference we are using for another molecules like hydrogen, nitrogen, okay, sulfur, chlorine, whatever molecule or compound you want. If it is written 1 mole, then the number will be 6.022 into 10 to the power 23, right? So now the mass of a 1 mole of any substance or any molecules is called a molar mass, right? So what is molar mass? What is molar mass? It is like mass of 1 mole of a substance, okay? Mass of 1 mole of a substance or particles or entities is called molar mass of that particular substance or entities or ions, whatever you are just writing, okay? Like particles, atoms, ions, molecules, in which format you want, you can put it. So this is the mole concept and molar mass, we have just cleared it. Later we'll see it for percentage composition, right? Okay, we'll see the percentage composition. So what do you mean by percentage composition? So percentage composition is, here it is asking that suppose one molecule is there, suppose water, it has given this water molecule, right? Now they are asking that in this water molecule, what is the percentage of hydrogen it is present, what is the percentage of oxygen element it is present in that H2O molecule. So how we are going to calculate? So percentage composition directly we can write is that the percentage composition of the particular element. Suppose I am calculating for hydrogen, right? So what we will write it here? It will be like mass of that element. What is the that element? Why we are writing that element? That element means which elements composition you want here, right? Suppose you want for hydrogen, you have to write mass of hydrogen element present. This will be complete. Element present in the given compound, right? In the given compound, divided by what will be the molecular mass. Okay, molecular mass of the compound here into 100. So percentage composition you will get it by this. See what is happening. Suppose for hydrogen you want, so mass of hydrogen element present in the compound, okay, and then molecular mass of that compound, so molecular mass of this water. So taking this as an example, percentage composition of hydrogen. How you are going to do it? Mass of hydrogen molecule in this, so there are 2 hydrogen is there, so 2 into 1.008, okay, divided by what is the molecular mass of this water? We know that it's 18, right? Into 100. Okay. So now what is happening? How we are going to calculate? So it is approximately 2, right? 2 divided by 18 into 100. So directly what we can do it? 2. Okay. And then here it will be 9. So 109. So how much it is going to come? 1. And then 1, 0, 10. 11 point. Then again 10. So 1. You just write this is the percentage of hydrogen is present. Now the percentage composition of oxygen. Okay, how much the percentage composition of oxygen is coming. Here is only one oxygen atom is there. So what is the molecular mass of this oxygen? Atomic number is 8. So molecular mass will be 16. So it will be 16, okay, divided by, and only one oxygen is there, so 1 into 16 divided by 18 into 100, okay. Here it will be 8, 9, so 800 by 9. By this method also you can do it, or one more method is there. Directly you can, what you can do is 100 minus 11.11. Directly it will come. How much it is coming? So here it will be 9, and then here it will be 8, and then again it will be, here it will be 9. From 9, 1, it will be 8, and then here also it will be 9. 88.89%. Okay, let's see how much it is coming. 9, 8 just 72, then again 72 means 8, 8, 80. So again it is 72. So again 8080. 72, here also 72, so 880. Again it will be 8. Then again 72, it is 8, 8 it is going. So now round figure we have to do it. So if it is more than 5, so this number we are going to change it to 89. Now this is the percentage, right? So whichever way you want, you can calculate it. Whether you want it through this, any one element, like for hydrogen composition you have calculated, then what you have to do it, from 100 you just do this subtraction, okay, you will get this number, right? Or else what you can do it, you have to calculate this percentage composition of oxygen, then also you will end up with the same kind of result, right? So this is percentage composition. Next topic, what is that? Empirical formula. Let's see what is empirical formula. We'll discuss the empirical formula. Okay. Empirical formula, right? So in this empirical formula, it will help you out to find out the molecular formula. Okay, we will discuss this by taking an example, and then it will be very much easy to solve this kind of problems. Okay, empirical formula and molecular formula. Okay, so we will take one example, one question I am having. Let me write the question. Okay, based on that I will calculate. A compound contains 4.07% hydrogen, okay, and then 24.27% carbon, 24.27% carbon, and then 75.65% chlorine. Okay, so 4.07% hydrogen, 24.27% carbon, and 75.65% chlorine. Okay, and its molar mass has given. So molar mass or molecular weight, I'll write it. How much it is given? 98.96 gram, right? 98.96 gram per mole. What are its empirical and molecular formula? So you have to calculate empirical formula and molecular formula of this particular composition, like whatever composition it has given. Based on that composition, you have to find out for this molecular formula. Okay, so how you will proceed it? Okay, so step 1, what we are going to do in step 1, we will do it by step wise. So first, everything is given in percentage, right? So let's assume that the molecular mass of this compound, particular compound, is 100 gram. Okay, let's assume that molecular mass of this compound is 100 gram. In that, hydrogen percentage is 4.07, then carbon percentage is 24.27%, 24.27 gram. Will not write percentage. Hydrogen containing is to 4 because we have considered 100 gram, right? So hydrogen content is 4.07 gram. carbon content is 24.27 gram, and then chlorine contents is 75.65 gram. Correct? Now in the next step 2, what you are going to do is, in step 2, just convert it to the mole, right? In the later chapter, I'll show you how, like whatever problem you are getting in the mole concept, okay? Everything you just convert it to the mole and then you solve it. Then there won't be any problem, okay? Solving those questions. So in step 2, just convert it in mole. So moles of hydrogen, how much it is coming? So given weight, how you are going to calculate moles? So given weight 4.07 divided by the molecular weight of hydrogen, right? So here, what is the molecular weight of hydrogen? Okay, moles of hydrogen, how you are going to calculate? This will be 1.008, right? How much it is coming? Approximately, you just write it down, 4.07. You can write it down, okay? 4.07 mole. Now moles of, what is that? Carbon. So carbon, the given weight is 24.27 divided by its molecular weight, right? Carbon's molecular weight is 12. 12 point something is there. We'll consider it 12 itself, right? So 12 to the 24 point. Again, we will write 2. Okay, 2.2. We will write it. Then next, coming to the moles of chlorine. How much it will come? Given weight is 75.65 gram divided by what is the molecular weight of chlorine? It is 35.5, right? So now how much it is coming? It is also approximately 35.5. It is 75, so it's 72 times. If it is going 70 and 2.2, approximately 2.2. You just take it, okay? In the next step, the step 3rd, what we are going to do is, based on this mole, we are going to frame the simplest whole number, okay? Simplest whole number we are going to find it out. Like the minimum one is, minimum value is 2.2, 2.2. So we'll find the ratio, okay? Step 3rd, we'll find the ratio. Ratio of what? Carbon is to hydrogen is to chlorine, okay? So this will be the empirical formula. Whatever ratio we are going to get it, that will be the empirical formula, right? Carbon, how much it is coming? 2.2 is to hydrogen, how much it is coming? 4.07 is to chlorine, how much it is coming? 2.2. Now what you are going to do it? The minimum value, it should be 2.2. The minimum value is 2.2. Just divide by 2.2. Okay, because we have to find the simplest, the lowest whole number, okay, or simplest whole number we have to find out. So divided by 2.2, 2.2, 2.2. How much it is coming? 1 is to 2 is to 1. So 1 is to 2 is to 1. So what will be the empirical formula? So empirical formula will be, see how many carbon are there? Carbon. How many hydrogen are there? 2. And then chlorine. This will be your empirical formula, right? This will be your empirical formula. Now how we are going to convert this one to the molecular formula? Let's see. This empirical formula, how we are going to convert it to the molecular formula. So simply you just take it, CH2Cl. This one we have got. Now what you have to do is just calculate the molecular weight of this particular empirical formula. How much it is coming? For carbon it is 12 plus 2 hydrogen is there, so 2 gram, and then 35.5. So how much it is coming? 0.5, 5 to 7 to 9, and then 1 and 3, 4. 49.5 gram it is coming, right? Now you have to find the factor. You have to multiply it, right? So empirical formula is the simplest whole number, and molecular formula is telling you the exact number of element present in that molecule, right? So to get that, we have to calculate this n. This will be the factor where we are going to multiply whatever the n factor we are getting here, that we are going to multiply with the empirical formula, and then finally we will get the molecular formula, right? How we are going to do that? So n will be given molecular weight of that molecule, right? Given molecular weight, how much? 98.96. So given molecular weight 98.96 divided by the empirical formula molecular weight. You have to write it. N is what? The given molecular weight of that compound. In the question it is given, and then divided by molecular weight whatever you got for empirical formula, right? This you have calculated, no? So 49.5. So now how much it is coming? Approximately twice it is coming, right? 49 into 2 is 98 and 5 into 2 is 1. So approximately it is coming n equal to 2. So now what you have to do is molecular formula equal to 2 into CH2Cl. So now how much it is coming? C2H4 and Cl2. C2H4 and Cl2. Right? What is this? Dichloroethane. Right? 2 carbon. Maybe chlorine will be in 1 carbon. Maybe it will be geminal, or maybe it will be vicinal. Okay, that we don't know. But we know that its molecular formula is C2H4C2. So it can be this. 1 chlorine is here, 1 chlorine is here, and then hydrogen, 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 hydrogen. This can be possible, and this is also possible. Chlorine, chlorine, hydrogen, 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 hydrogen. But you see, 1, 2, 3, 4, 4 hydrogen. Okay, what is that? 4 hydrogen, 2 chlorine, 2 chlorine, 2 carbon, 2 carbon. Right? So now from the empirical formula we know that how to calculate molecular formula, and from percentage composition how to calculate empirical formula, that also we have seen. Correct? Now next is 1 second. Next will be your stoichiometry and stoichiometric calculation. Okay. What is stoichiometry and how stoichiometric calculation will take place? We'll see. Stoichiometry and stoichiometric calculation, how it is happening, we'll see. So stoichiometry and stoichiometric calculation. So suppose we are taking one example, we will take it. It is in gaseous form, methane, and then we are burning it with oxygen. Okay, in presence of oxygen, what is happening? We are getting carbon dioxide and then water. It's a simple, right? And we are getting water. So how many molecular water we will get it? So 4 is there. So here it will be 2. So everything is balanced now. Okay. So the stoichiometry or stoichiometric calculation is what? Stoichiometry will say that the element, whatever element is this side, whether it is balanced or not. Okay. So it should be balanced. Okay. That is only stoichiometry. And the stoichiometric coefficient, what is the stoichiometric coefficient? For oxygen, this is 2. Stoichiometric coefficient. For methane, it is only 1 because nothing is there, so it will be 1. For carbon dioxide, it is 1, and for water, it will be 2. So now, just listen, 4 line I'll write here. That 4 line will be helping you out throughout the problem, whatever problem you are going to solve it in future from the mole concept, it will help you out with this 4 concept. So first will be like, we have to convert everything in the mole. 1 mole is reacting with 2 mole of oxygen. 1 mole of methane is reacting with 2 mole of oxygen, and what is getting? 1 mole of carbon dioxide and 2 mole of water, right? So everything you have to convert it to the mole, correct? Now the second one is 1 molecule. Okay, 1 molecule of methane is reacting with 2 molecule of oxygen, and what you are getting? 1 molecule of carbon dioxide and 2 molecule of water, right? If you are writing based on molecule, you have to write like this. Now again coming to the volume, okay, volume in STP, standard temperature and pressure. How much volume it will come for 1 mole? It will come 22.4 liter of methane is reacting with 2 into 22.4 means 44.8 liter of oxygen. What you are getting? 22.4 liter of carbon dioxide and then 44.8 liter water you are getting, right? here one thing, everything will be in gaseous form, gaseous state, right? Now one more thing is that, like for methane, how much you are taking? 12 plus 4, 16. 16 gram of methane is reacting with, it will be 32 into 2, 64. 64 gram of oxygen, what you are getting? So it will be 12 plus 32 plus 12, so it will be 44. 44 gram of carbon dioxide and 18 into 2, 36 gram of water you are getting. So this 4, it is looking very easy, but in your entire chemistry journey, wherever you will solve this mole concept problem, okay, normality, molarity, whatever you want to solve, then limiting reagent, find the limiting reagent, whatever you want to solve it, these are the values which you required, okay, and this is based on this stoichiometry and stoichiometric coefficient. How we are getting here 1 mole and 1 mole is reacting with 2 mole? Because we know that here the stoichiometric coefficient is 1, here the stoichiometric coefficient is 2, so 1 mole is reacting with 2 mole, likewise we are getting, right? So everything you just convert it to the mole and then you write the product, so it will be easy for you to calculate. Like for example, I'll take it here, I'll just rub this thing and down I'll write it here. You just solve it and tell me how much gram you are getting the product. Suppose I am taking 8 gram of methane, right? So what will be the mass you are getting here for carbon dioxide? What will be the mass you are getting here? Okay, how you are going to calculate it? Write it down, the answer. Okay, so how much mass you are getting? How you are going to solve it? First this 8 gram you convert it to the mole and then you will get it, right? We know that 1 mole methane, we are getting 1 mole of carbon dioxide. Let's see, for 8 gram. So how you are going to convert it to the mole? The number of moles of methane will be like given weight 8 gram, and what is its molecular weight is 16. So 8, 2. Okay, so how much it is coming? 1 by 2. Then the mole is 1 by 2 means 0.5 mole. If 1 mole methane you are taking, you are getting 1 mole product. If you are taking 2 mole methane, you will get 2 mole carbon dioxide. If you are taking half mole methane, you will get half mole carbon dioxide. Now, if you are getting half 1 by 2 mole methane, you are getting product 1 by 2 mole of carbon dioxide. Now, you have mole, just convert it to the how much amount it will come. How it will come? So it will be like mole of carbon dioxide equal to given weight W divided by molecular weight, right? Mole already you know it is 1 by 2. So write it here, 1 by 2 equal to the given weight we are going to calculate, right? This mass we are going to calculate. Molecular weight we know is 44 gram. So cross multiply, okay? So it will be how much here? 2. So 2 W equal to 44. Now given weight, the weight mass of the carbon dioxide produced will be 44 divided by 2. So it will be 22 grams. So now how much mass you are getting here? 22 grams. Correct. So how you are getting? Whatever amount it is given here, just convert it to the mole, okay? And then mole to mole reaction you do it. Because you know here 1 mole is giving product 1 mole. So half mole will give product half mole, and based on that half mole, you just calculate, okay, because you know that mole equal to W by a molecular weight, given weight by a molecular weight. So molecular weight you know, mole also you know, so just calculate this W, how much it is coming? 22 gram, correct? So now what is the limiting reagent? We will see the limiting reagent and then we will bind it up today, and tomorrow we will solve the questions, right, based on this. Whatever concept we have learned today, tomorrow we will discuss the problems. Okay, limiting reagent. So what is limiting reagent? Limiting reagent means, suppose one reaction is there. This is the reaction, N2 plus H2, we are getting NH3. So how much? 2, so 2 it will come, 6, so here it will be 3. So in this type of reaction, what is happening? To the reaction, like reacting like this side, the reactant side, Suppose we required for 1 mole of nitrogen, we required 3 mole of hydrogen, then only we are producing 2 mole of ammonia. Suppose we have only 2 mole. We don't have 3 mole, right? We have only 2 mole. Can we get it, this 2 mole product of ammonia? We can't get it, right? So this will be the limiting reagent. Now this will be acting as a limiting reagent because it's required 3 mole, but you have only 2 mole. So if you have only 2 mole, then how much ammonia it will be generated? So it will be like 3 mole is giving you 2 mole. So 3 mole is giving 2 mole. So 1 mole will give you 2/3. And then how much you have? 2 mole you have. So 2 mole, how much it will get? 2/3 into 2. Likewise, so 4/3 mole of ammonia you will get it. Not 2 mole. You will get it 4/3 mole of ammonia, right? So likewise, you have to calculate. So this is the role of limiting reagent. Limiting reagent means any of the reactant will be get over, and because of that, your reaction will be limited, right? So this is the limiting reagent. Hope you like today's class. Tomorrow we will discuss the questions, okay? So happy learning, happy reading. Thank you.